Hello, my dear students. Today we are going to see a small topic in the chapter of carbon and compounds, known as chains, branches, and rings. So, as the heading suggests, it is showing the property of carbon to form long chains, branched structures, as well as rings. So, consider a compound having four carbons in it. So, it can be arranged like this, arranged like a chain, which each carbon is connected to the next in a head to tail fashion. So we will try to write the structure like this. We will fill up hydrogens like this. How are we feeling like this? Because carbon is tetravalent. That is, each carbon in a molecule will have four hydrogens. No, not four hydrogens. Will have four bonds around it. So here, if we count, there are 1, 2, 3, 4 bonds around this carbon. Here, this carbon also is having 4 bonds, 1, 2, 3, 4 bonds around it. So likewise, we can write the structure of this linear or chain compound like this. This C4H10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogens. And now we will see the branched carbon compounds. Same number of carbons as that of this first compound, but it is arranged in a branched fashion. So here we will try to write all the hydrogens to complete the tetravalency. So this carbon will have 4 bonds around it. And for this carbon, it will need 1 hydrogen bonded to it. Then only it will have 4 bonds around it. And for this carbon, it will need 3 hydrogens around it. Similar is the case of this carbon. Then only all these carbons in this molecule will have, the skeleton will have 4 bonds around it. Here also the formula is like this, C4H10. This type of molecules are structural isomers because they have same formula, same number and type of atoms, but they are different in their structure. So the carbon's property of forming chain as well as branched compounds is the reason behind development of structural isomers in carbon compounds. And we have learned that there are 2 types of compounds that are saturated and unsaturated. What is saturated? Saturated means all the bonds in the compound is single bonds. Any other element, if all the bonds are single bonds and there are no multiple bonds, no double bond or triple bond, this kind of compounds are known as saturated compounds. Then what is unsaturated compounds? Unsaturated compounds means there is multiple bonds in a molecule. There is either a double bond or a triple bond between the atoms of the molecule, atoms in the molecule. Then that compound is known as an unsaturated compounds. And these compounds having only carbon and hydrogen in them are known as hydrocarbons. Carbons are composed of hydrogens and carbons only. So this even so both linear or chain as well as branch structures are examples for hydroform ring structures also. For example, this skeleton having 6. So to satisfy the tetravalent, we will add have 4 bonds around it. So this is molecule C6H12 or cyclohexane. And if the skeleton is like this, I want to C, and alternate familiar compound. Can you say which is this? This is a molecule of benzene. For hydrocarbons, if it is completely saturated, there is no multiple bonds. If there are only single bonds, they are called as alkanes. And if there is a double bond, if there is 1 or more double bonds, then that compound is known as alkene. And if there is 1 or more triple bonds in between the carbons, that compound is known as alkyne. So this is about compounds of carbon and hydrogens only, that is hydrocarbons. So hydrocarbons are named like this: alkane, alkene, alkane, based on the number and type of bonds in between the carbon atoms. And this carbon property of carbon is that other than carbon itself, it can go and bond with other heteroatoms, other elements like oxygen, nitrogen, halogens like chlorine, bromine, etc. So association of this carbon into these heteroatoms will generate another class of compounds, which is which will have their own names and itself. And thus groups of atoms or elements that are attached to this carbon will be known as a functional group. For example, if a heteroatom like chlorine or bromine is attached to an alkane, that class of compounds will be known as haloalkanes. If chlorine is added, it will be known as chloroalkanes, and if bromine is added, it will be known as bromoalkane. And the functional group in this compound is Cl, Br. If it is chloroalkane, the Cl is the functional group, and bromoalkane, if bromine will be the functional group. And it can go and have high affinity for, and carbon has high affinity for oxygen, also oxygen heteroatom. And bonding with oxygen will generate this class of compounds, this class of specific compounds. For example, this, if the carbon is directly attached to OH group, that compound, that type of compounds is known as alcohols. So OH will be the specific of that class of alcohols, specific part of that type of compounds. So OH is known as the functional group of alcohol. Then there is aldehyde. So aldehyde, if the carbon is attached to doubly to an oxygen and an hydrogen, this functional group is known as aldehyde. So this is the functional group. We'll also write it as CHO. So CHO is the functional group known as aldehyde. There is ketone. Ketone is there when the carbon is attached to two other carbons and doubly attached to an oxygen. So this is known as ketone. And then there is carboxylic acid. Carboxylic acid is obtained when carbon is double bonded to an oxygen and an OH group. So it will be also carboxylic acid. So like this, there are so many compounds of carbons that are present or that are made in laboratory. Why we are saying this is that carbon can form stable compounds with other carbons as well as other heteroatoms, which will generate a wide range of compounds. That's why carbon is present in such abundance in nature. So we will see about carbon and its other properties in the later classes. I hope everything is clear for everyone. And thank you for watching. Happy learning.